Earlier, we defined radian measure as theta equals S over R. If you take this formula and solve it for S, you get the formula for arc length, which is S equals R theta. For our first example, putting this formula into play, we are asked to find the length of the arc intercepted by a central angle theta in a circle of radius r. And we have on example A a radius of 12.3 inches, and our angle theta is 12 pi over 3 radians. It's really important that you remember that all of these formulas require your angle measure to be in radians. So this one is just going to be putting the formula into play. And remember, we are finding arc length, which is the letter S, equals R 12.3 times theta 12 pi over 3. And if you put that all in on your calculator, you should get 154.6. Now, when you are talking about arc length and you want to put the label on it, the measure of the arc length is the same measure as the radius of the circle. So if the radius is measured in inches, then the arc length is also measured in inches. On example B, our radius is 71.9 centimeters and our theta is 135 degrees. It's important for you to note that our theta is in degrees this time. So the first thing that we have to do is rewrite theta in radians. So we're going to take 135 times pi over 180. If you multiply and simplify, you get a theta of 3 pi over 4. So now we know our correct angle in radians, so we are ready to find S equals our radius, 71.9, times our theta, 3 pi over 4. Multiply that all out on your calculator and you will get 169.4. And again, the measurement of the arc is the same as the measurement of the radius, so it's in centimeters. On example 2, we are asked to find the angle measure. That means if you are looking for angle measure, you are looking for theta when you have a given radius and arc length. So we are going back to the version of the formula of theta equals S over R. Remember, arc length is S and R is radius. On problem A, we are given that radius is 7 and arc length is 6. Both of these are measured in meters. So to find theta, we are going to take the arc length, which is 6 meters, divided by the radius, which is 7 meters. Meters over meters cancels, and if you take 6 divided by 7, you get 0.9, and theta is always measured in radians. On problem B, we are told that our radius is 11 centimeters and our arc length is 20 centimeters. So to find theta, we're going to take arc length, 20 centimeters, divided by radius, 11 centimeters. The centimeters over centimeters cancels. Take 20 divided by 11, you get 1.8. Theta is radians. A sector of a circle, by definition, is the portion of the interior of the circle that's intercepted by a central angle. When I think of this, it always just looks like a piece of the pie to me. Anytime you have cut a piece of pie, you have been cutting a sector of a circle. We want to be able to find the area of the sector of a circle. So how do we find that area? A sector is just a piece of the circle. So we are going to use proportions to help us find this area formula. The proportions that we are going to use are first that the area of the sector is just a piece of the area of the circle. So we're going to put area of sector over area of circle. And that has to be equal to the length of the intercepted arc compared to the entire circumference of the circle. So what we are doing in this proportion is we are comparing piece to whole has to equal piece to whole. So what we are going to do then is substitute the formulas that we know into these proportions. Since area of the sector is what we're trying to find and we don't know the formula for that, we're just going to put area of sector in the numerator of the first fraction. We know that the area of a circle equals pi r squared, so that goes in the denominator. Equals in the second fraction, we know that the length of an arc is r theta, and for the denominator, we know that the circumference of a circle is 2 pi r. We need to solve this proportion now for area of the sector. In order to solve for area of a sector, we have to take both sides times the reciprocal of the denominator or multiply by the denominator on both sides. So we now have r theta over 2 pi r times pi r squared over 1. If we do that multiplying, then we get theta pi times r cubed now in the numerator, and then the denominator 2 pi r. But if you look at this, we can cancel pi over pi, and we can take 1r out of the denominator and out of the top and leave 2 of them. And that will give us our final formula for the area of a sector. Our final formula for area of a sector is 1/2 times r squared times theta. Now that we know the formula for area of a sector, we're going to put it into practice. Our example 3 says find the area of a sector with the given radius r and central angle of theta. Remember, theta is in radians on these. When we look at A, theta is already in radians. It's 5 pi over 2, and our radius is 7 inches. So we are just going to put the area formula into practice. Area of our sector is 1/2 times the radius squared times the angle measure in radians, 5 pi over 2. Put all this into your calculator and you should get 192.4. Our label will be in the same units as our radius, which is inches, but anytime you are doing area, that must be squared. On our second example, our theta is 72 degrees and our radius is 51.3 centimeters. Notice that theta is not in radians, so that has to be the first thing that you do. So we're going to do theta equals 72 times pi over 180. Multiply and simplify there. You should get 2 pi over 5 as your angle measure. Now to find the area, you're going to do 1/2 times the radius, 51.3 squared, times the angle measure, 2 pi over 5. Do that all on your calculator and you should get 1,653.5. Our units are centimeters, area means squared. On example 4, we have a sprinkler system provides water to a sector-shaped field as shown, and we have a picture showing you what the field looks like. This is just the sector of a circle, and we are asked to find the area of that field if theta equals 40 degrees and r equals 152 yards. So this is just an area of a sector problem, but the first thing we have to notice is that our theta is in degrees. So we're going to convert theta into radians by taking 40 times pi over 180, multiply and simplify, we get 2 pi over 9. So now we have our theta in the correct units in radians. We can find our area. It's 1/2 times the radius squared times the angle measure, 2 pi over 9. Put all that into your calculator and multiply. You should get 8,064.8. We are measuring in yards and area is squared.